Hello everyone, welcome to my YouTube channel Code with Aryan. If you want to learn data structures and algorithms from scratch, then this series is for you. We'll learn DSA using Java, starting from the basics, gradually moving towards interview level questions and problem solving. So, whether you are preparing for college, placements, coding interviews, this course will help you build a stronger foundation. So, without wasting any more time, let's get started. Before we begin, let me quickly explain how this course will work. So, this course is for complete beginners. So, even if you are new to DSA, you can follow along. In every lecture, we'll first understand the concept, then do dry runs, implement codes, and solve some LeetCode problems. This way, you will understand the concept instead of just memorizing it. Now, let us have a look at the roadmap and the syllabus. So this is the syllabus provided by the university, and we'll start from module 1, introduction to algorithm analysis, linear data structures, trees, and go through each module one by one. And this is the roadmap for module 1. So these are the topics mentioned in the syllabus, which are basic algorithm analysis, running time calculations, asymptotic notations, best average and worst case, time complexity and space complexity. But I feel there are some extra topics which we need to learn for more understanding of module 1. So we'll do it whenever needed. So this will be our approach while studying any topic or any algorithm. First, we'll know the intuition, the theory behind it, dry run the algorithm, code in Java, analyze time and space complexity, try to solve some LeetCode problems, and then revise. So, today's topics are introduction to basic algorithm analysis, characteristics of a good algorithm, why do we need to analyze an algorithm, and advantages. So, let's begin. So, the first topic is basic algorithm analysis. And the first question we get is, what is an algorithm? In simple words, an algorithm is a step-by-step procedure to solve any computational problem. For example, suppose to make a cup of tea, you first boil water, then add leaves, then add milk, sugar, and finally filter it to serve it. So we followed a particular procedure to make the tea. So the procedure is called the algorithm of making tea. Similarly, in programming, whenever we want to solve a problem, we divide it into small steps. These small steps are called algorithm. So we might often get confused among algorithm and program. So we can say they are not same. An algorithm is simply an idea, and the program is the implementation of that idea in a programming language. So suppose I explain the steps to find the largest number in an array, but when I write those steps in Java, Python or C++, it becomes a program. So we always design the algorithm first, then implement it using a programming language. So we can find the following points as the difference. First is design, second the knowledge, domain knowledge. So as we took an example of explaining the steps to find the largest number in an array, we might need the knowledge of what is an array and what is a largest number and how to find it. But we don't need the knowledge of the programming language. So we can write the algorithm even if we have the domain language, but the program can only be written by a programmer. The algorithm can be written in any language. Program can only be written in programming languages. Algorithms are independent of hardware and software, whereas programs is dependent. And algorithm are need to analyze, whereas program is tested after the execution. So the next topic we have is priori analysis and posteriori analysis or testing, which is the two ways to analyze an algorithm. Or we can say this priori analysis is the way to analyze an algorithm, and posteriori testing is a way to test the program after its execution. So here we analyze an algorithm the before executing the program, whereas this is tested after the program is executed. It is language independent and it is language dependent, of course, because we need to write it in any programming language. It is hardware independent and it is hardware dependent. And last, we find time and space functions to find time and space complexities for an algorithm, and here we get runtime and memory in seconds or milliseconds or bytes and megabytes respectively for a program. So the next topic is characteristics of a good algorithm. So what do you mean by a good algorithm, and how do we characterize an algorithm as a good or bad? So these are the following factors which determine if the algorithm is good or bad. So the first factor is input. An algorithm is known as a good algorithm when it has 0 or more inputs. Similarly, an algorithm is known as a good algorithm when it has 1 or more outputs, because an algorithm or a program should always give us some output. Third, definiteness, which means every step should be clear and precise. Fourth is finiteness, which means there should be finite number of steps. Effectiveness, which means the solution should be practical and executable. And correctness, which means the code or the program or the algorithm gives us the expected output. So next, now we might ask, why do we need to analyze an algorithm and how do we analyze? Suppose there are two algorithms and both are correct. So why do we need to analyze them? Imagine one algorithm solves the problem in 1 second and the other one takes 1 minute. Both are correct, but obviously we'll prefer the faster one. Similarly, one algorithm uses little memory and other one uses very high memory. We'll prefer the one using little memory. In some application, we also care about network usage or battery power consumption and hardware resources like CPU registers. Let's take a program of swapping two numbers A and B. We'll make a temporary variable and give the value of A to it. We'll give the value of B to A and give the value of A, which we stored in temporary, to B. Now, how do we analyze an algorithm? We can just think of it as one assignment take 1 unit of time, one assignment take 1 unit of time, another assignment take 1 unit of time, and third assignment take 1 unit of time. So total 3 units of time is taken. We have 3 variables A, B and temp. So we are taking 3 units of space because each variable is taking 1 unit of space. So this is how we analyze the time and space complexity, but this is very basic. We'll learn more in the next lectures. So let us summarize the advantages of algorithm analysis. It helps us compare multiple algorithms. It helps us choose the most efficient solution, and it improves the overall performance of software. It reduces unnecessary memory usage, and ultimately it helps us design better software and more scalable software. So that's all for today's lecture. In the next lecture, we'll start with our first major topic, running time calculations, where we learn how to calculate the time complexity of algorithms step by step. If you found this video helpful, consider liking the video and subscribing to the channel so you don't miss the upcoming lectures. Thank you so much for watching. I'll see you in the next video. And if you have any doubts, you can put it in the comment section. Happy coding.